Welcome to Baskaran's Think Differently. If you have not yet subscribed my channel, kindly subscribe. Thought 82 is an interesting problem frequently asked in almost all the competitive examinations. You have to find the number of triangles in this given figure. The triangle is divided into 5 parts, 1, 2, 3, 4 and 5. You have to find the total number of triangles, smaller and bigger triangles in this figure. For this, we consider single lines, smaller triangles, then 2 lines, 3 lines together, 4 lines and all the 5 parts, 5 lines together. Also, there are 2 categories of triangles. One, the upward triangle, the other, the downward triangle. First, we count the upward triangles. In single lines, you start from here, you have 1, 2, 1, 2, 3, 1, 2, 3, 4, and in the bottom we have 5 upward triangles. So altogether there are 1 plus 2 plus 3 plus 4 plus 5 triangles in single lines. Now we go for 2 lines. You consider the first 2 parts. Altogether you have 1 triangle. Then you leave alone the first layer. Here you have 2 upward triangles. You come here, for each vertex you will get 1. 1, 2 and 3. And in the bottom you have 1, 2, 3, 4. So in double lines you have 1 plus 2 plus 3 plus 4 triangles. Now you understand the pattern. There is a definite pattern. In 3 lines you will have 1 plus 2 plus 3 triangles. You can easily check. For 4 lines you have 1 plus 2 and for 5 lines you have 1. We have not added them, we will add them in the last. You will have a shortcut method. Now we go for the downward triangles. You first consider single lines. In the first line there is no downward triangle. You require 2 vertices minimum. So in the second part you have 1 and here you have 1, 2. Then you get 3 and in the bottom you have 1, 2, 3, 4 downward triangles. So you have 1 plus 2 plus 3 plus 4 in the single lines. You go for double lines. Consider here, you don't get any triangle. You consider this part, you have 1 and here you have 2. So along the double lines you have only 1 plus 2, 3 triangles. Now we go to 3 lines. We consider number of downward triangles. For the first 3 parts you cannot have any because you need 4 vertices minimum. 3 lines. Here you can have 1, 2, 3. 3 lines you have, but downwards you have only 2 lines. The third line is not there. So you cannot have any downward triangle for 3 lines. Similarly for 4 lines and 5 lines. So these are all the triangles available. Now how to count them? To count, you consider the number of parts. There are 5 parts. You write 1, 2, 3, 4 and 5. Now start counting. You keep 1 as it is. We have cumulative sum. 1 plus 2 will be 3. Why we do this? This 1 will take care of the number of triangles in 5 lines. And 1 plus 2, 3. You get number of triangles in 4 lines. Similarly, you consider 3 plus 3, 6. You get this. 6 plus 4, 10. Then 10 plus 5, 15. So this way you get all the upward triangles. Now take the sum. 15, 25, 31, 34, 35. Now we count the downward triangles. You have 1 plus 2 plus 3 plus 4. We don't get 1 plus 2 plus 3 plus 4 plus 5. So we leave this. We take 1 plus 2 plus 3 plus 4. Then you don't have any 1 plus 2 plus 3, so you leave it. You have 1 plus 2, take 3 and you leave 1. So start from the bottom, leave it, then choose alternative terms. This way you get the number of downward triangles. Now 15 plus 10 plus 3, 13. Adding we get 48. So the total number of triangles in this diagram is 48. Think differently.